Hello, this is the practice set for proportions problems. Please like and subscribe if you find this video helpful, drop a comment or ask a question to engage, and check out the many other lessons and videos that we have on the channel. So as always, pause the video to work these problems on your own and then come back to check your work. Okay, now I brought a calculator. There's a calculator around here somewhere, and now I can't find it. So just bear with me. We're gonna get through it. Uh, I don't think I'll need a calculator for the first part, but some of these have some numbers that I didn't exactly vet. So for the first several problems, it's just solve this proportion. And what I tried to do with these is change them up a little bit. So you'll notice in these first two, the X is not in the same position all the time. And that's to bust us out of using like just trying to memorize where numbers go. Okay, we want to keep the foundational concepts in play. So the idea is if these are equal ratios, then the cross products will be the same. So 3/4 equals how many out of 10? So this will be 4x. Now you can write 3 times 10 and then change it to 30. Typically, I'll just skip right to the 30 if it's something that I know how to multiply, and then we'll divide both sides by 4. And then because I don't have a calculator, 4/4 is 1. And what I notice is that I can reduce that fraction and find basically an equivalent ratio of 15/2. So that would be your simplified fraction, or you could write 7.5, 7.5. Okay, so that would be the first one. Second one, our variable is on the bottom or in the denominator, and that is on purpose just to make sure that we remember our cross multiplication. So 6 times x is equal to 5 times 2, which is 10. Divide both sides by 6, and that will simplify to 5/3. And I think I would leave it like that. The decimal equivalent to that is what, like 1.2/3, 1.6666666, like forever. So I don't think I would, typically if it doesn't like round off to a nice decimal, we don't change it over. All right, so moving on. So now we get into ones that just look a little bit different. So we have 1/2, or 1/2 is equal to 3x/12. And you might be able to do this one in your head. Okay, now I'd like it, if I were giving this to my class, I'd say still show me the procedure because I want you to practice the idea. But what's awesome is if you copy the problem right. There we go. But if you can do this in your head, maybe if you think about what we're doing here. So remember, to get equal ratios, you multiply by some value. And so 2 times 6 would give you the 12. So that means you'd multiply by 6 on the top. So what that means is that 3x has to be equal to 6, which means that x must be equal to 2. And so that's a great way to reason your way through it. It would show fluency. If you did it that way, you should be able to explain to the teacher what you did. So I noticed that 2 times 6 would give me the 12. Therefore, 3x would have to be equal to 6 because that's half of 12. And so 3 times 2 would give me the 6. And you could just kind of talk your way through it. If you go to the procedure, which sometimes we just need to practice the procedures. It's not that the procedure is better. Okay. In fact, I don't think the procedure is better in this case, but we need to practice it. So 2 times 3x is equal to 1 times 12. 2 times 3 is 6. And therefore, we'll divide both sides by 6, and x is equal to 2, which we already had reasoned out had to have been the answer, but you can get there with the cross multiplication. Now, once you get to problems that look like number 4, that they become harder to do in your head. I think this one you can do. I think I wrote it so that it was fairly easy to do. I think the answer is on 9, and you could reason it out the same way. So you reason, okay, to get there, I had to multiply by 2. Because 4 times 2 is 8, therefore 5 times 2 is 10, which means this has to be equal to 10, and therefore x would have to be equal to 9. So that is an okay way to do it. If you did it that way, please grab your pencil and copy down this way of doing it, just because it's a good exercise. So this is 4 times x plus 1, and you do need to group the x plus 1 there, because a fraction bar acts as a grouping symbol. Okay, and so everything in that numerator is being grouped together. So when you're kicking it out of the fraction, you've got to replace that grouping symbol. So x plus 1, it was like all like coming together as a family, got to still come together as a family. Now we'll have to distribute. So 4x plus 4, 5 times 8 is 40. Subtract 4 from both sides, so 4x is equal to 36, and divide both sides by 4. 4 divided by 4 is 1, and 36 divided by 4 is 9. You could also have done this, where you divided by 4 before you did the distribution. And so 4 divided by 4 is 1, leaving you with x plus 1 equals 10. And you could get there that way as well. So several different ways that you could get there. But remember that the point, I often ask my students, it's like, what's the point of the homework? And they'll often say, to get a grade. No, not to get a grade. The point of the assignment is to practice a particular skill. So in this case, the point of this assignment, this practice set, is to practice your cross multiplication. So if you did these problems by reasoning them out, first of all, great. Okay, that is awesome. And if you were my student, I'd be super proud of you for doing that. And also, I would still want you to practice the procedure for times when you have like really yucky numbers and you can't just look at it and figure it out, because there will be times when you'll need to go back to that cross multiplication. All right, this one has the x, it's in 2 different places. So we've got 2x plus 1 over 5 equals x over 3. And this is one where really, if you were relying on your reasoning and your intuition and your number sense, all of which are wonderful things, it falls apart here because you've got the x's on both sides. So figuring out what that ratio, what that number is that you're multiplying or dividing by to get from a 5 to a 3 or 3 to 5, it's not a nice number. It's not like we doubled it or cut it in half. It's something more complicated, and then you have the x's in both positions. So this is a problem where you need to go back and fall onto that cross multiplication. So if these ratios are equal, then I know that the cross products will be equal. So this would be 3 times 2x plus 1 equals 5 times x. 3 times 2x is 6x. 3 times 1 is 3. And you can do this a couple different ways. I'm going to go ahead and subtract 6x from both sides to get 3 equals negative 1x. And then divide by negative 1, and I get negative 3 is equal to x. You might also have done something like this, okay, after you distributed. Some people like to keep the x's positive. So 6x minus 5x is x. And just remember, if you did that, 5x minus 5x is 0. And then you would subtract the 3. Okay. So either way, you should get negative 3. Negative 3 is the answer to that. And you really do have to fall back onto cross multiplication. Do I know that when I have 2 equal ratios that the cross products will be equal? All right, now we get to the fun ones. Yay, fun ones. All right. In the third term, you earned 346 out of 420 possible points. So I grade my classes, most of my classes, most of the time on what's called a points system. So every assignment has some kind of points value. So a test might be worth 100 points, and a homework assignment might be worth 10 points, and an in-class activity is 25. I don't know. And at the end of the quarter, there were so many points that students could earn. Maybe we had 15 homework assignments, so we had 150 points coming from homework, and we had 2 tests, so we had 200 points coming from tests, and whatever. At the end of a particular quarter, you look at all the points you earned and how many points you could have earned. So this is your ratio. You earned 346 out of 420 points. And you want to know what percent that will be. So 346 out of 420 is how many out of 100. And you can do that multiple ways, but we are doing proportions in this lesson, which means that we are going to cross multiply and get 420x equals 34,600. Okay, I just did the multiplication out. And then we will divide by 420. And I'm going to have to do that out. 34,600, right? And I get about 82.4. Now, the question was, what letter grade will you get? Well, for most schools, a 32 would be either a B or a B minus, depending on whether your school does pluses and minuses. My school that I work at just does it's a B. My school that I went to as a student, you had to hit the 3 to get the B. So this would have been a B minus, just barely a B minus, a little bit more, and we would have had a B. Now, if your school has a different scale, so it could be that an 82 at your school is actually a C or a C plus. However you answer that, just the important part is the percentage. All right, next one is another conversion problem. So if €1 is $1.16 or $1.16, how many euros will you get if you exchange $100? So I'm going to go ahead and we'll do dollars and euros, but you might have set that up a little differently. So we're going to put $1.16 is €1, and we are exchanging $100, and we want to know how many euros that is. So 1.16 times x is equal to 100 divided by 1.16. And how many euros will we be getting for our $100? And this one I think you can also do out. You could also reason it out. 86.2. 86.21. Yeah, okay. Euros. Okay, so I guess that makes sense. It should be a little bit less than the 100. If we ended up with something greater than 100, we would have an issue. So if you look at the original ratio here, the amount of euros is less than the amount of dollars. So if you're trading in or exchanging $100, it should be less than $100. So it's a little bit of a check. Just make sure that your answer makes sense. Okay. If 1 inch equals 2.54 centimeters, how many inches will be in 10 centimeters? And what I find some of my students do is they like to rely on conversion sheets and then methods that they have been taught for doing conversion. So if I'm converting this way, I will multiply by 2.54. If I convert this way, I will divide by 2.54. And they'll ask me am I doing it right? And I'm like, I do it with a proportion. So I don't memorize whether I got to multiply or divide or, where. I just always do it with a proportion. So 1 inch is 2.54 centimeters. So my other ratio, I know the 10 centimeters, so that's going to go on the bottom where I decided to camp out my centimeters, and then my how many inches is the numerator. So we have 2.54x is equal to 10. And I tell them, like, listen, if you do it this way, it will always work all the time. You will not have to memorize whether you're multiplying or dividing. Like, these will always work. All right. And so I have a 3.94 inches. And you might want to double check, like, does that make sense? So 1 inch is 2.54 centimeters. So I just want you to notice this is the lesser number and this is the bigger number. And so if you have 10 centimeters, this number should be less than 10 centimeters. How much less? Like if you ended up with 9, you might have some red flags go off, but there you go. All right. So just shy of 4 inches. Find the missing side length. Okay, so this one, again, I mentioned in the video lesson, I didn't want to get into how do you know that these figures are similar. Okay, that is a lesson for a geometry class. In fact, you might do a whole unit on this. When I taught geometry, we'd have an entire unit on similar figures. But what we do want to look at are the two triangles. So we have the smaller triangle, which has a vertical piece of 1 and a horizontal piece, a vertical piece of 3 and a horizontal piece of 1. And then the larger triangle, which has that height of 12, and this is actually 1 plus x. Okay. And so we can decide how we want to do this. I'm going to do vertical or horizontal, but you can do either. And the ratio of vertical to horizontal in the small triangle, which is 3 to 1, will also be the ratio in the big triangle, which would be 12 to 1 plus x. So this right here is 3 times 1 plus x is equal to 12. 3x, right? 3 plus 3x is equal to 12. Subtract 3 from both sides, so 3x is equal to 9. And x must be equal to 3. Now, there's other ways you could set that up. I set it up as vertical over horizontal, and that's the way I did it in the lesson. So typically when I do it a particular way in a lesson, most of my students will mimic me. They will say vertical over horizontal, but you could do this. You could do the small triangle to the large triangle, okay? And then compare the vertical pieces. So 3 to 12 is the same as 1 to 1 plus x. And you'll notice if you cross multiply, you will actually get the same thing. And so that's one of the properties of proportions that I remember going through when I taught geometry. And it essentially means that you have multiple ways that you could set up your proportion for that, and it would work both ways. Okay, last one. On a map, 1 inch is equal to 50 miles. So here's some scale factor on a map. If two cities are 3.5 inches apart on the map, how far apart are they in real life? So 1 inch is equal to 50 miles. Therefore, 3.5 inches would be how many miles? We don't know, but we're going to find out. 1 times x is x. And so we just need to do 50 times 3.5. And what I've had a lot of students do when it's something like that, where it's 1 to something, is they know without thinking too hard about it that they need to multiply by 50. And that's generally fine. Oh, that's not right. It's a 5. There we go. And so they'll just say, okay, well, 1 is to 50, so 3.5, I multiply 50 by 3.5, and they'll get there. But a lot of students will not know if they need to divide or what they need to multiply. And so setting up the proportion either will help you navigate through that or it'll confirm that you're doing it the right way. All right. Well, I hope that you enjoyed this and saw some practical applications of proportions. Please like this video if you found it helpful. Subscribe for more math help. Drop a comment, question below, and check out some of the other videos on the channel. We have a whole playlist for help on Desmos, a playlist on multiple choice help, algebra tiles, and an entire Algebra 1 curriculum. Everything you wanted to know about lines, go nose around and see what you can see. And I hope I see you in a future video.